In a previous video, I took a look at a Dell / IBM LTO-8 tape drive with an eye towards using it for backups of stuff behind me in the basement. In that video, I talked about taking the tape drive out of the external enclosure and putting it into a dedicated backup server that would run the tape drive and putting it somewhere else in my house. My concern at the time was that the tape drive might be too noisy for the basement in that constant winding and rewinding of the tape. Turns out the tape itself wasn't that noisy. The drive enclosure was kind of noisy, and so I've kind of changed tactics. Though, this is the second time I tried to make this video. The first time, and yeah, so surprisingly hard to find a case with even a 5.25" drive bay on the consumer side of things, but I think I have one that'll work. So the case, as I'm sure you saw, is a Silencio S400 from Cooler Master. And let me just bring up the description of the case and the pricing and stuff. Silencio gets to carry. He's the smallest, looks almost like a kid, he doesn't use, and if the cops grab him, he can't talk. Or anyway, about the stuff. So that's the case. At least I think it is. It's theoretically a good case for the purposes that I wanted, of it being silent and relatively compact and also desktop format. But end of the day, I decided that I would rather put the tape drive down here in the basement, and therefore it should be rack mounted. Oh, the reason I didn't use that case is also because the motherboard I bought right here didn't fit. And that was a mistake on my part, but also the description of the case was a little iffy. This is a mini ATX motherboard, deep. Like, the deep is after mini ATX. Anyway, the case said it would fit a micro ATX or ATX motherboard, and I was hoping a mini ATX, even with the deep qualifier, would fit in that case. It did not. That case is really only for micro ATX, so this motherboard was never going to fit in it. Regardless, I think rack mounting it down here in the basement is a better choice. And that case, well, it solved the noise problem because, as you saw, the front of it is completely innocuous, but that's because it has a door, single 5.25" drive bay, perfect for the tape drive, and it has sound dampening material on the door and on the inside of the case panels. So no window on the side of the case. It's not meant to be like an RGB sort of build. It's meant to be, I guess, like a stealth build. Nice and quiet, also nice and dark. Perfect for my application in theory. What I realized after trying to go down that road is that noise isn't the thing I should be most concerned about. What I should be most concerned about is dust, because the front of the tape drive is fairly open to airflow, and I don't want to be drawing a ton of air into the drive and getting the inside of the drive dusty for obvious reasons. Back in the day when we had floppy disks and optical media drives, that was a concern because dust could get sucked into those drives, gunk up the heads or the optical sensor, and cause problems. Nowadays, we're not really so concerned about that because not many of us have optical drives, less so even floppy drives. So with it, and I guess less so even tape drives, but with a tape drive, yeah, that's a concern. So I got a new case. Well, I definitely can't accuse them of poor packaging. I mean, it's like double corrugated boxes nestled inside each other, and lots of foam around the edge. As you might have seen from the box and my on-purpose way of dumping it out, this is an iStarUSA D-Storm Series 3RU rack mount chassis. Obviously, it's a rack mount chassis. And these have been around forever. I mean, I think I remember seeing these like over a decade ago. So the thing that ended up drawing me to this case as opposed to any other rack mount chassis is that it has these doors in the front, which is great for physical security because they do lock with this little latch. But more importantly, they have filters in them. So that should cut down the amount of dust that this server ingests. And specifically, the tape drive will be located here, where this 5.25" drive bays, and so it'll suck in air through the filter. And so this case should be more than big enough for the motherboard that I purchased. I'm just hoping the power supply fits, because the power supply is front mount, and they actually include a power stub out that comes from a connector in the back. This isn't made of the thickest metal. I mean, I would say it's like the equivalent of a mid-range desktop chassis. Do you really need this aluminum crossbar? I mean, I could probably do without it, right? I don't really understand how... I mean, it helps rigidity. It helps the sides from pushing in or pulling out, but they're not that flimsy. Yeah, I think we could do without this crossbar. And taking this crossbar out is probably a good idea anyway, because getting the motherboard in with that in place is going to be a pain. And it's pretty easy to remove. It has a couple of tiny screws on each side. Yeah, and it's not like... I mean, the sides move. It's not super flimsy. I think it'll be fine without that, honestly. Here's the thing. It looks to me like this power inlet and this fan are on a separate piece of metal that seems like it would occupy the same size as a small ATX power supply. Maybe too small, though. That's probably the problem. No, that's going to be smaller. That's going to be a small ATX power supply. I don't think a full-size one would fit there. We're going to try, but I'm pretty sure it's front mount for the extra space that would afford. And based on the screw holes here, I guess these are for 3.5-inch drives. Like, you could stack 4 of them in this mounting bracket. I'm just going over this stuff in case any of you want to buy this case. You can get an idea of what it's like. Also, the reason this is a 3-rack unit case, and I think I see why that bracket was across the top now, because it doesn't have much rigidity in that direction. It tends to twist a lot. But that's probably not as much of an issue as it sounds, because there's a separate motherboard plate on here, and that has bent over sides, so that should be pretty rigid independently of the case, but I don't know. Yeah, so I probably will put this back ultimately when I'm done mounting the motherboard. So the reason this is a 3RU height case is because I wanted stand-up PCIe slots. I didn't want to have to get a riser with a right angle and then hope it lined up with the slots in the case. At least this way I can use full-height PCIe cards. Although, honestly, I could have done with half-height, but just in case I want to use this for something else in the future, I'd rather just have the option of using all these slots and having full-height cards in them. Also, let's talk about these fans. I don't know what kind of quality these are, and it's also missing one, which could be populated there, and I do want to populate one there. And so that's why I got these Noctua fans. One 80mm to replace that large one, and then two 60mm to replace the smaller one and fill in that blank area. The Noctua girl recently got in trouble for fronting an alleged scam coin. And yeah, now when I see Noctua, I just think Noctua. It's unfortunate for their brand. And Noctua fans are known for both being ugly and also of extraordinarily high quality, and for being generally very quiet. And these are PWM 4-pin fans, which should be compatible with the motherboard. Also comes with a little extension cable, splitter cable, and low noise adapter, which I guess, what does it have, a resistor in it or something? Don't know. Vibration dampening mounts, and regular screws. I actually like the way they look. In a sense, they have that kind of like, they remind me of the Famicom, sort of the same color scheme almost. And obviously these are going to be in the ass end of a server, so I don't really care what they look like anyway. And there are two very important mysteries which I now must solve. And that is, will the motherboard fit? And will the power supply I have fit? Wow, these fans come with... And these are only 3-pin fans. Long cords, though. I'm actually going to remove the fans for now just to get these cords out of the way. Why am I doing this like a schmuck? And for those of you that are curious, that's the 2 fans that were in there. Definitely glad I made the choice to replace them. They're extremely light. They feel flimsy. I will keep them in my box of spare fans, though. These big flat cables are the USB 3 connections in the front, by the way. So, first, the motherboard. And just for posterity, here's the motherboard specs and the price, because I did buy it off Newegg. Oh, I was calling it Micro ATX Deep. It's actually Deep Micro ATX. Whoops. And one notable thing about this that I wanted is it has 2 RJ45 10GB Ethernet adapters with an Intel chipset. It also supports 12-volt DC in, which might be useful if I ever want to bury one of these underground. Huh. And here is that board. I already opened this, but it's got some SATA breakout cables. SATA power, that is. It's got this, I guess this is the 12-volt motherboard connector. Mounting brackets for the heatsink. This is an LGA 4677 socket. Backplate. Manual / diagram. A breakout cable for SATA ports. It's got a mini SAS connector to 4 SATA connectors. And the board. Importantly for me, it has 4 16-lane PCIe slots, which turned out to be really hard to get because I was looking for a desktop motherboard at first, but I could not find a micro ATX or small size ATX motherboard which had either 10 gig Ethernet adapters built in. I could not find any of those, or multiple 16-lane or 16-lane and 8-lane PCIe slot. A lot of them you'll see have 2 16-lane PCIe connectors, but when I read the manuals, when I looked into it, one slot was 16-lane off the CPU. The other was usually 4-lane off the North Bridge. And for right now, I want to put a 8-lane SAS HBA in one slot and an 8-lane 10 gigabit NIC in the other slot. That might sound weird because this has 10 gigabit NICs, but I need fiber right now. One of my plans in an upcoming video is going to be about a 10 gig copper switch. Right now, all I have is a 10 gig fiber switch. So for temporary purposes, I'll put a fiber NIC in here. Well, a NIC with SFPs, but I'll put a fiber SFP into it and not use the onboard ports, but the onboard ports will be great for the future. And just for future expansion, I like to have as many 16 or at least 8-lane fully wired PCIe slots for additional cards. Also 8 DIMM slots. That's more than you'll find in most compact consumer motherboards, so eventually I could put a lot of RAM in this. To start things off, I have 64 gigs of DDR5. And also that RAM is ECC RDIMMs, and for mission critical data like backups, I'd rather have that kind of RAM. So I'm not mounting this yet, I just want to make sure it will physically fit inside the chassis. Which, yeah, it looks like it will. Although, we got to be careful the PSU isn't too long, because that's all the clearance we have there. Although, I probably will be able to mount a PSU here if I have to. And we'll just leave the motherboard in there nice and loose while I talk about the power supply. So I'm thinking, yeah, a more compact power supply here might be the better solution. Not to sound like some grumpy out of not to sound like some grumpy out of touch stick, but this is why I usually just order computers that are pre-made by Dell or HP and then upgrade them, because at least I know all the parts fit together. So it looks like we have about 120 millimeters of clearance from the inside of this lip to the bottom of the chassis. That's with a little bit of a safety margin. I mean, maybe I could go 124 millimeters, but that's pushing it. And then right to left, it looks like the PSUs will be about 110 millimeters wide, just based on the screw pattern. And then depth, we're not really worried about. There's plenty of room there. So it's going to be less than half the width of this back plate, but I mean, that's okay. I don't care if there's a gap there. Yeah, alright, I'm just going to get an SFX-sized power supply. It's technically not the right size to replace this back plate because it's going to only come out to about here, like from here to here. But it'll mount with 2 screws. I don't care if there's a little gap. I'll try to get the gap on this side just so that, you know, you're not really able to like reach into the motherboard for whatever reason. Not that I would. I just realized this has cutouts for DB25 connectors. That's old school. Let me do some ordering off Amazon and or Newegg or whatever. See how quickly I can get that power supply and a new fan. And then we'll move on from there. Yeah, so forget that power supply. I got a SF1000 from Corsair. It's a 1000 watt SFX power supply, which isn't really supposed to fit in this case. Like, the screw holes are not going to line up, I don't think, but it will physically fit. There might be a little bit of a gap next to it too. It's a compromise. iStarUSA does sell a power supply for this, and you can get this with a power supply already installed. And I did look for either that PSU sold separately or one that would fit in this chassis. The iStarUSA one was a redundant power supply. I'm not sure about the efficiency. It was fairly expensive. I could only find it through a random third-party seller. But I found an Athena power supply that I think would have fit, but it had an 80+ bronze rating, and I want either gold or platinum. This, by the way, is a platinum, but it says cybernetics platinum, not 80+, but still, it should be fairly efficient. So let's get this back plate out of the way. And then I'm probably going to also need to take out this hard drive carrier too. I almost can't believe this thing's 1,000 watts because it's tiny. But hey, it's from Corsair, it's a reputable brand. This also has a silent operation fan, which won't spin at all under extremely low or no load. As you can see, physically it fits in there just fine. The only issue is it's technically too small because it's got this gap here, but I can just find or fabricate a metal plate to fit in next to it, or even plastic. It doesn't matter because it would just act as an air baffle. In theory, I guess I could actually use a metal plate to connect to these two screws here and here, but as it is, I don't think that's really going to be necessary. And then these two screws should remove the hard drive mounting bracket. Correction, 3 screws. And there we go. And unfortunately, the power switch doesn't let it get close enough to this part of the case to actually seat any screws. So I think I'll have to mount it that way. Now that's actually interesting. The actual mounting holes for the PSU are in the 4 corners. And obviously you can see that's not going to line up with a hole there or a hole there. I could drill one, that's not a problem. But interestingly, you can't really see it through. Yeah, you can see the screw head right there and the screw head right there. So the 2 screws that hold the lid on the power supply are actually in exactly the right position to hit 2 of these holes. So I might just take those out and replace them with larger screws. Not too long, of course. I don't want to impact anything inside the power supply by going through there, but you can see there's a screw coming down from the top right there and another one there that's covered by a sticker. So I doubt there's anything electrical right in this corner that this screw would impinge upon, especially because it looks like the fan is behind there, and that's probably the fan case. So I'm going to take a peek through the vent holes, but yeah, it doesn't look like there's anything electrical in there. They look like the typical fine thread computer screws. I mean, it's a little bit improvisational, and it does like wiggle a little bit, but it's not going anywhere. It's not like going to fall out. This actually kind of reminds me of being a kid again, because when I was a kid, like a teenager, I never had computer parts that fit together or that I could order exactly what I need. I always had to bodge whatever I could find and, you know, make everything work together. So this kind of reminds me of the good old days, or bad old days, depending on how you look at it. Oh, and that reminds me, because we're losing that 80mm fan that was going to be in that back plate here, I figure why not put a fan up here. It's vented up here in the chassis anyway. That's where the PSU would have gone. Why not force some air through? And so I got 2 different options. I got a Noctua 120mm and a 92mm. I ordered, it said 100mm when I ordered it, but 92 is fine. And I think the 120mm should fit. The only reason I got the fallback is also just in case like it didn't quite line up, it wasn't quite neat enough. So yeah, oh, 120 will fit nicely right there. See, there's just a little more than 120mm clearance here, and I just wanted to be sure that whatever fan I got would fit, which this will. And I'm kind of hoping, because it comes with these rubberized mounts, which have gigantic heads on them, so I'm hoping I could line one of these up, or 4 of these up rather, with the vent holes, and just, again, not have to drill or modify the case at all. Yeah, see, that's another thing I was afraid of. There's actually a lip behind this, and the fan goes down below that lip, so you can see the hole for mounting is right there. But if I raise it up so that that hole is visible through that vent, the top hole goes up behind the vent, and it's like kind of lines up with the intersection of the plate back here and this thick piece of metal up here. So it'd be hard to even get that drilled out and get a screw in there after I drilled it out. It'd have to be drilled so close to the edge. So that 92mm fan might come in handy. Quite a bit smaller, obviously 28mm smaller, but it's kind of a better fit, and those holes do line up real nice. Alright, and those silicone mounts are genius because they just fit right through these holes, clip into each of the corners of the fan, and now the fan's in there pretty solid, and it's vibration dampened as well, so I really love that. It was just a little tricky to get the two bottom ones in because there's not a lot of room for my hands down there, but hey, it's in. And then the other two 60mm fans should be much easier. I think I'm going to screw those in probably though. And there we go. Should have really good airflow in this case now. And it should stay relatively quiet. Okay, the return of the motherboard. Let me put the plate in here because the number of times I've forgotten to do that over the years is kind of silly. And then you gotta unmount the entire motherboard to get this in. Voila, that's what it's gonna look like. So this case obviously has screw holes for all sorts of different motherboards and configuration of screw holes. I have this, it's a long nib marker. Real handy once you have the board lined up. You can just mark all the screw holes through the holes in the motherboard. You know, you make sure the hole's lined up, then move it over, draw the line, and then you'll have a little line next to each hole you need to put a standoff in. And then I like to count just to make sure I put enough standoffs and I don't miss one. I got 1, 2, 3, 4, 5, 6, 7 mounting holes. See, got a little red mark next to that one, a little red mark next to that one. And otherwise it can be hard to remember if you want the one in that screw hole or that one, for example. Like this is really perforated. And then you always want to double check that you do see a standoff behind each one of those holes. And that's why it's good to have the count of how many standoffs you put in, because you want to make sure you see that many through these holes, because there's always the chance you could put the standoff in the wrong screw hole. Even if you did mark it, yeah, everyone makes mistakes, right? And then you might have a standoff like here behind the board. You might have put an 8th one in by accident, not thinking, and that might short something out on the bottom of the board. So always good to make sure everything counts out correctly. And then I always like to just tighten down the standoffs just a little bit extra, because otherwise what happens when you go to remove the motherboard from the chassis eventually, or if you realize you didn't put in like this plate or something, when you go to unscrew the motherboard screws, sometimes it just spins the standoff and you have a standoff stuck to the bottom of the motherboard. If, let's say, this is the first one I unscrew and the standoff spins with the screw, the standoff is going to lift off the base, but none of the other standoffs are, and so you're going to end up pushing the motherboard up in the middle and bending the motherboard. Probably not good. So if you do run into that situation where you start unscrewing a screw and you see the motherboard start to rise up a little, immediately just tighten it back down, take off all the other screws, and then do that one last, because this way it'll push the whole motherboard up at once, and then you can take the standoff from the back of the motherboard. Then the last thing you can see, there's a little bit of movement there, and that's because the plate most of the time has ground clips that are springy to make contact with the motherboard, and so they'll actually push the motherboard back a little bit. And so another thing is you want to make sure that before you tighten down the screws, you got everything nice and centered up as best as possible. Just because if I put a screw here in the corner, if these are really springy, it could push the board out on this side, and even though you might have all the screws in place, they might not be perfectly centered in those holes, especially if the motherboard's a little generous with their drill diameter. And that just helps you in the long run to make sure all your PCIe slots are aligned and everything fits nicely afterwards. And finally, I guess the last piece of advice would be you want to make these screws tight, but not too tight. Like, you want to make them tight enough they're not going to pop out and the motherboard's not going to be able to move around. But you don't want to over tighten it and risk damaging a trace either on the surface or in one of those layers by really torquing it down. Like, you can use one of these, of course, if you want, but I would be very careful and set it to a very low torque setting if you're going to do that. I prefer to do these by hand. If I'm screwing something into the case, like just metal on metal, I might use one of these. But a real delicate PCB like this, you know. Oh, and I forgot grounding. I'm always terrible about grounding myself, and I almost never wear a wrist strap. But what I do usually do that I forgot to do this time is I'll usually take a grounding clip. This plugs into the mains. I have this plugged into the ground. You don't want to plug it into the wrong hole. That'll be a bad time. But plug that into a ground, clip that onto the case somewhere solid. The idea being that you keep one arm, hand, whatever, in contact with the case. That'll discharge any static as you're working with the components inside. And alternatively, you could just leave the computer plugged in with the power switch off. It'll still be grounded from the AC outlet, and you'd have the same situation basically. And so I could have just plugged in this power supply, because right now it should be grounded to the chassis via the mounting holes. I didn't use the legitimate mounting holes. Actually, will this even get a good ground to chassis? Because it's all paintwork everywhere. There's no good metal on metal contact. Maybe something to test later. So next is the CPU. I ordered this from Newegg. It came in this 4 CPU carrier. Well, they can be stacked, so you could have tons and tons of CPUs in a very small volume. But not only is this packaging a little extra, Newegg really went the extra mile. This is how they sent the CPU to me. This box and the sub box and all this packaging was just for a single CPU. And not even a terribly fancy CPU. It's this Xeon Silver 5th Gen 4509Y. So 4 cores, 2.6 gigahertz, 4.1 overclock. It's only 125 watts thermal design power, so it's not terribly power hungry, and it's not going to emit a huge amount of heat, which is good because we don't have a lot of fans in this case. Man, those laser etch markings are so fine, but yeah, there we go. Actually, I shouldn't have touched the top of it because oil from your hand or any debris that you accidentally get in there can interrupt the thermal interface. There's the bottom. Oh, I'm not grounded. And we can't discuss the CPU without the CPU cooler, compatible with LGA 4677 sockets, which is what this is. It's got a PWM controlled fan. I forgot about that. I didn't even think of this. I bought this with the other case in mind. It would have had more than enough clearance because I checked, but in this case, not so much. Well, shit. Alright, I guess I'll cut here, and I'll have to order a new fan and heatsink. As long as we're talking about the CPU, it makes sense to talk about the heatsink and fan. This is from Silverstone XE02 for 4677 socket. Now, this heatsink is sold for a 2 RU server, so it's quite compact vertically. It's got one fan in the middle, heat sinks on either side, and PWM for the signaling. And it comes with heatsink compound pre-installed, so all we gotta do is attach the CPU, throw it into the chassis on the motherboard, and we're good. The only reason they didn't get a 3U heatsink is because, well, they're available, but they're not terribly common, and I couldn't get one delivered relatively quickly, so it would have slowed this project down even more. The only thing that stopped me from going with the 2U heatsink in the first place is because this has a smaller diameter fan, and therefore might be louder. But hey, if this is too loud, I can always get a 3U model. It'll just take a while to get here, and I can swap it out later. I guess we could take our first look at the socket together. Ooh, looks like a CPU socket. Oops. Okay, now we want the airflow going in this direction, and the CPU is going to be oriented like this. If we just flip the CPU onto there, it should all line up. And there we go. Now the CPU should be properly aligned on the heatsink. Just make absolutely sure the 2 little notches are lined up with the pins here. Double check airflow direction going out the back of the case. Cool. And then just drop it straight down. There's latches in all 4 corners before you screw it down. And then all I need is a giant Torx driver, T30. Yeah, probably a little too long of a screwdriver, but need a little bit of depth. And I'm just going to bottom each one out, but not really put any torque on them yet. Well, Torx. And look, I don't know if this is strictly speaking necessary, but I'm just going to go diagonally, just by feel, torque them all down about the same. And there we go. No need to over tighten, just need to sort of get them all the way to the bottom, just snug. Reasonably long cord. So I believe those are all the case fan headers right there. And I'm just looking for these CPU fan pin headers. I thought at first I was going crazy because they show all the system fan connectors, but not a single one of these is for a CPU fan. And you would usually think a CPU fan pin header would be right near the CPU. But then I looked at the back at the CPU installation instructions, and this motherboard, they may plan for it to be used or intend for it to be used with a fanless heatsink, like in the type of chassis where the chassis fans blow air over the heatsink, not a separate heatsink fan. So my wager would be So I plugged that into the fan 1 position, and I'm hoping that in the BIOS you can map that to be a CPU specific fan. And I'll figure out what I'll do with cable management a little later, although, yeah, I'm not really sure how I want to route that. And then we have this cable coming from the fan that I put in the front of the chassis, and that is just about long enough to reach the motherboard. It's not too tight. It's not pulling too hard on the connector or anything. But then on the opposite side, these short pigtails definitely will not reach those connectors. But fortunately, Noctua included extension cables with the fans, so that is obviously perfect for this. So this is probably going to be a messy cabling operation. Unfortunate. And the pin headers for the fans are 6 pins wide. You only need 4 for each fan. The additional 2 pins are for a status LED for each fan, so it could indicate fault or running. I may, eventually want to gussy this up with some extra LEDs in the front just for fun, but for now, I'm not going to worry about it. Hopefully these high quality fans won't be too prone to failure. Okay, I made those fans 2 and 3, so from the back it'll be in order. Yeah, it ain't pretty, but it'll work. There we go, that's what I was looking for, because I hate when they don't label it on the board. Ugh. So as you can see, the power LED plus and minus are right next to each other, but as you would find on most power LED connectors, there's an empty space between the positive and negative. So I'm not concerned with the hard drive LED, so we're just going to use the HDD LED. Alright, and then unfortunately this only has USB 2.0 headers on the board, so the USB 3 connector here, and it's only for I think 1 port. Although it is blue. It says USB 2 in the manual, but it's blue port, so I would think that would be USB 3, but unfortunately not going to fit this connector. There is a fan indicator LED on the front, but I think it's off of this cable. I'm not sure how that's wired, so worry about that later. I might try to get that working. And I should point this out because this motherboard can take just 12 volts in. It also has an adapter for the ATX connector, and this is it. I thought originally this was for 12 volts, like if you were spying the computer with 12 volts, but I guess this is just to let the computer communicate with the power supply, and then the actual power comes from these 12 volt headers. And you can see that's how that works. Okay, well I guess we'll just populate A1 and G1. Yeah. And for RAM, I've got these Micron 32 gig sticks. They're DDR5 4800 RDIMMs. And yeah, not much more to say about that. And there you go, out of the package. And then for the SSD, I got one of my old standbys, 990 Pro, 2 terabytes. The only reason I got such a large disk, relatively speaking, is because I might want to use the disk for buffering of data as it's being fed to the tape. Because like I said, it's going to be reading off the network. And you'll notice it doesn't have a heat sink on it. I guess during buffering it might be doing a lot of writes, but they're not going to be at super high speeds. And there we go, I just need to find the screw that came with the motherboard. And of course I got screws and crap everywhere. Oh god, of course it's got like a plastic, this is stupid. It's got a plastic top to it so it won't magnetically attach to the screwdriver. And then it's got this coin cell battery that's vertical right next to this screw hole. So I can't even get my fingers in there to get the screw started. Well, or barely, And of course because it's a plastic screw, well at least the top is plastic, the shaft was metal, but I just tore it right up with that screwdriver. But anyway, the SSD's in there, so that's great. And the only other thing I wanted to check is that this has 2 SAS ports on it, but I'm pretty sure they're just for SATA. Yeah, it's just for SATA. Just kind of hoping I was wrong and that these 2 connectors were actually either optionally SAS or SATA, but SATA only, so we will have to use the HBA, which is what I figured. If that's not a surprise, that's fine. The pleasant surprise would have been if those were SAS ports for some reason. Alright, now I just got to figure out how to run the power in here without making it into a complete rat's nest. So, here are all the modular cables the power supply came with. And of course we do need the full-size ATX power connector, just so we can use this adapter to bring it back down to a tiny 4-pin connector. It's kind of unfortunate. I guess they could make my own cable here, but not gonna. I mean, we got plenty of room in the case for this extra cable slack. Alright, I mean, that's not too bad. Just got it looped around there. Just got to figure out a way to secure it to the case. Okay, so the bottom connectors are all 12 volts. Yes, these connectors will all be 12 volts. Alright, that should be fine then. Just wanted to double check. And yeah, okay, it is the same pinout. Just wanted to make 100% sure that this didn't have some kind of wacky special pin configuration, and I was going to blow up the motherboard with these connectors. I think I only have 2 of these CPU cables, but I'm going to wager, and we'll check this, that these are all in parallel. Yeah, all the 12 volts are common together on all these connectors, as are the grounds, obviously. I mean, the grounds I expected, I just wanted to make sure. So I think for this being a relatively low power CPU, at again 125 watts, I think we'll be okay with 2 of these connections. And I think we got enough stuff in this thing right now to power it on, so let me just get a VGA to HDMI adapter and see if it works. Alright, let me get this in frame just in case it blows up or we get magic smoke or something ridiculous happens. We can all share in the moment together. So I'm plugging in the power supply, but I don't have the switch on. So I'm going to turn on the switch, I guess now. Okay, it didn't blow up. That's cool. And then where is the power button? On. Oh yeah. Fans are spinning. Whoa. I'm just bringing the microphone in. Yeah, that CPU fan is a loud little beast. The Noctuas are basically making no noise, but that could just be spooled up initially on boot. So anyway, let's see what we got on the VGA output. Nothing yet. Oop, I dislodged the VGA cable before. Okay, we got some post messages here. Oh, there we go. We got video. We got video. And the fan spooled down a lot. Yeah, now the fan's just blowing lightly. This is good news. This is all very good news. The fan keeps spooling up and down. Yeah. The fan just keeps throttling up and down. Heatsink's not hot at all, though. So that's good. Oh, there we go. F2 or delete. Cool. Oh, and in the lower right-hand corner where it says B4, that is being shown on the motherboard as well. I just don't like these BIOSes where it says F2 or delete to run setup, and then when you hit those keys, it doesn't change the status of the screen. There we go. It is, and then it finally says entering setup. So you don't know if it took the input or not, because sometimes it doesn't initialize the keyboard or the USB subsystem until, you know, a few seconds into that process. You might hit delete, it might just miss it. Hopefully I can change those fan parameters because it keeps just throttling up and down. Like, oh, now it just throttled up fully. Yeah, it keeps throttling like very hot, very fast, and then basically down to idle. Yeah, we already knew the specs in the CPU. Just want to make sure it's looking good. Yeah. The date time is, well, the date is actually correct, but the time is wrong. Oh, cool. I like this a lot. You can bifurcate this, well, quadfurcate this. No, wait. 1, 2, 3, 4, 5, 6, 7-furcate a PCIe slot. Wow. That's, oh wow, even more. Okay, that's great. Cool, and it's got the fan tachometers on there. It's just throttled up. Is that updating in real time or no? It doesn't look like it. Okay. I just realized it's not just the CPU fan that keeps throttling up and down. That's just the most audible. The Noctuas are veritably silent, but they're throttling up and down in step with that because I can feel the airflow difference, even though I can't hear them at all. Okay, maybe this setting somewhere else to deal with the fan that I'm not finding or seeing in the manual. Alright, I'm sure I'm missing something. Let's just save and exit. Let the fan throttle up and down all at once. What's even cooler, and I mean that quite literally, is that the fan in the power supply is not even moving. Yeah, I mean, the power supply itself is actually pretty cool. It's slightly warm on this side, but overall very cool because it's so efficient. It doesn't need to run the fan unless it exceeds a certain temperature internally. And right now it's quite comfortable with just putting the CPU at idle, DRAM refresh, I don't know, powering whatever the NVMe is taking right now, which is not much, and the fans. Power consumption in the system is going to be minimal, so that fan's not even turning, which I like. And also I like that the center line of the CPU is just about on the center line of those two fans. and the airflow direction from the CPU is of course going that way, so it'll blow that way and air will get sucked out by those fans. The problem is the CPU fan is more powerful, so I'm hoping that somewhere I can change the fan settings, like to run these at a higher RPM than this one, for example. Or so I could set thresholds like to run the different fans at particular temperatures. And I'm not looking for it to be silent, you know, I would still be conservative in my settings, but, you know, also I'd want, like I said, these fans to run a little harder than this one so they move more air. Because otherwise what happens is, if the CPU fan is blowing air faster than these two fans can evacuate the air, that's going to create an airflow situation where some of the air will leave the chassis off the heatsink for the CPU, but other air will just come back into the chassis and just get circulated around. Which isn't necessarily terrible, it's just not desirable. Like ideally, whatever air this is spitting out, you would want to go right through the back of the case and get sucked out by these two fans. And also I would like to throttle up this front of the case fan as well, because right now it's turning, but it's blowing very mildly. Like I can barely feel the airflow, and I do want it to give a good shot of air across the PCIe slots. Alright, I shut the computer off for the time being because I want to just throw in the NIC and the HBA. This is a Broadcom 57414 chipset. It's only PCIe 3.0, but I think so is the HBA. It's 25 gigabit max, which is more than enough for me at this point in time. And then the HBA. Oh, I'm gonna need a high profile bracket for this though. Since I got those off eBay, they didn't come with high profile or full height brackets, but fortunately I got a collection. SMC PCI WLAN. That's old. That's a classic. I guess the problem is you'll notice most of these are half height brackets in here, because mostly I use full height brackets. Even my 2U servers, I use the full height brackets and, you know, on an angle. So I might just try to use this old HP bracket, even though it's not really suited for the HBA with this giant space here, but I want a vented bracket. And as long as the screw holes line up, which they do, it'll be fine. And so you can see it's got that hole in the back. I think this was for an external HBA. Alright, so that bracket is not a perfect fit. It's riding like maybe a millimeter high. I used to swap these all the time on various cards, and so I found that if the bracket doesn't line up perfectly, it's a little too tall, you can just throw a washer in between it and the case. And there we go, now it sits perfectly. Maybe that's, I don't know, is that too ghetto for some of you? But it works quite well, and card's not going anywhere, so that's the important part. So I'm going to take a break from this for a few, and see if I could find more information about the fans and how to control their parameters, hopefully. And then what I want to do is a airflow test on this chassis. I'm just kind of curious to see where the air is going to go. I got a little handheld smoke machine. Well, let's just get to it. Since the next day, I think I solved the fan issue, and also I took a look at the web GUI for the IPMI, which was actually really good. Let me show it to you real quick. And this is probably a me thing, because like I said, I've primarily just purchased old Dell and HP machines off of eBay, and so I'm familiar with DRAC and ILO. I haven't really messed around with any like actual motherboard manufacturer, and so this is actually decent IPMI interface, or web version of the IPMI interface. Of course, it also does support sending commands via IPMI using IPMI tool, for example, on the command line, or other management applications. However, for my purposes, this will do me just fine. This is a screenshot from my main workstation where I was doing this. So what I did try to do was update the firmware on the BMC. You can see here it's running version 2.03, and the latest version was 4.01. So I downloaded the file off ASRock's site, started the firmware update process. It liked the firmware file that I uploaded just fine, validated it. As you can see, the firmware image has been verified, blah, 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 and it just stopped on uploading. And then the CPU fan, notably, because that's the most audible one, kicked up to 100%. And I figured, okay, it's doing the firmware update. And obviously, you can't control the fans during a firmware update, so it defaults everything to 100%, which makes sense, because that'll keep it as cool as possible. But it stayed in that state for over half an hour. I went upstairs because I got bored of waiting, but I also didn't want to turn the machine off and interrupt it. And eventually, it apparently just finished, and the fan speed went back down to near idle. I went and logged back into the BMC, and lo and behold, it's still at firmware version 2.03. For the life of me, I cannot find an error message anywhere. So for now, I'm satisfied enough with the functionality of 2.03. I didn't look at all the release notes, but it doesn't look like they did a lot of bug fixes, at least for the latest release, which granted I think there's probably an intermediate release. I couldn't find any information on this, but maybe I have to upgrade to an intermediate version first before jumping to version 4, like version 3 something. I'm not sure. So for now, this is slightly outdated firmware version. I think this is the firmware date, March 2nd, 2023. So it's old, it's not super old. For now, that's fine. So then we go to the dashboard and we can talk about the fan. So fan 6 was where I hooked up the front fan, that 92mm Noctua. And as you can see, 971 events in the past 30 days, 1203 events. I mean, this is just today, almost 1,000 events. And if I hover over this, you'll see it says fan 5. That's because I tried moving the fan from its position here on the fan 6 connector to the fan 5 connector next to it. Still had the same problem. And I missed it yesterday because the way I'm sitting and looking at this, my view is blocked kind of by the side of the case and or this cable. But I did look back at the footage and I caught it, and there is a red LED, as I'm showing you right now, next to the fan connector that blinks, or rather turns on when there's an issue with the fan. And I actually only saw the LED secondary to log into the BMC and seeing the fan problems. And basically, if I was messing around with it, if I just scroll down a little bit, you'll see all these are pretty much the same. Reading that triggered event, 0 RPM. And then when it goes back to 600 RPM, that's where it's deasserted because the condition is fine. And as you can see, it kept going from 0 RPM to 600 RPM, sometimes 700, over and over again. And so here's the issue. There's nothing wrong with the fan itself, as best I can tell. The issue is that the fan is a PWM fan. So it gets 12 volts power. It also gets a PWM signal, which looks like this. And the faster you want to run the fan, the higher the duty cycle, the more this line will be on in whatever period of time. And so you have a situation where the BMC is signaling to the fan in PWM, and PWM really is just a percentage of duty cycle. In other words, how much of any particular time period is this signal railed? Now this could be a positive voltage and this could be ground, this could be a positive voltage, this could be a negative. It doesn't matter. The point is that the PWM signal will only be on for example, 75% of the time or 25% of the time, 50, and anywhere in between. So the BMC signals to the fan using PWM, and it can only tell the fan, I want you at 25% speed, 50% speed, 75% speed, which will be represented in that PWM signal. The problem is the BMC doesn't know for any particular fan what 100% speed is. For example, this is a 2000 RPM fan, max. So when the PWM signal is on, solid on, this should operate at 2000 RPM. The BMC doesn't know that. Now, on the other hand, the fan does have a tachometer. So every time it spins around, it'll trigger a sensor in the fan, which then goes on another pin of this fan connector and signals to the BMC the fan has made a single rotation. So if the BMC tells the fan, I want you to have a 10% duty cycle or spin at 10% of your rated RPMs. For this fan, that would be 200 RPM. I think, as best I can tell from experimenting around with it, when this was at 200 RPM, the BMC was not seeing it as turning. It was seeing it as 0 RPM. And so when it's reporting that the fan was at 0 RPM, I don't think that was the case. I think the fan was operating too slowly. It might have been at 5% duty cycle or even less than that, where the BMC expected in that sampling time to see that sensor being triggered, but it didn't because the fan was spinning slower than the BMC really expects it to, and therefore it assumed it wasn't spinning at all. So then it would throttle all the fans in the system up, including the front fan, to a higher duty cycle. That would hit 600 RPM, and the event would be cleared because it would be able to register that with the tachometer. So I'm pretty sure that's what's happening. It's because the BMC is essentially sending one type of signal to the fan to control it, but getting a different signal and different metric back on how fast the fan is actually spinning. And I think at very low rotational speeds for this fan, the BMC wasn't able to detect that it was rotating at all. Now, fortunately, it does have a fan settings section, and it's quite comprehensive. So, for example, you can set duty cycle based on the temperature of a sensor, and even include some hysteresis so the fans aren't constantly going up and down in speed. And there's also a ramp up and ramp down. It makes the server more pleasant to listen to at the very least. So you can assign fans to different sensors. So for example, if you had a fan on the NVMe, you could have it look at the M2 sensor. And well, there you go. You can see all the various types of sensors it can support, and you could set which table is appropriate for that. So that is awesome. I did not fool around with it too much because that Noctua in the front of the case is really freaking quiet. I mean, it's barely audible at 100%, but it's also relatively low CFM. It doesn't move a lot of air. So I figure I'm just going to run it at 100% duty cycle all the time. So I changed fan 6 to run at 100% for the manual setting, and then in the fan mode table, you could set each fan to run in a different mode, and I set fan 6 to manual. Honestly, the rear fans are also pretty low CFM, or a pretty low flow rate if you don't want to measure it in cubic feet. You can measure it in cubic meters, whatever you want. But in any case, the flow rate is fairly low for these fans. Like, I can feel it. I haven't measured it scientifically. So I might just run these at 100% all the time because, like I said, they're also very quiet. The CPU fan, extremely loud. The CPU fan is a different problem. I'm pretty sure I got a faulty unit because in my lifetime I've opened up, I dare say, hundreds of servers. And I mean, most of them don't have the fan in line in this configuration. There'll be usually a row of fans on a rack mount chassis. And of course, when you power a server on or open the lid, the fans usually spool up to 100%. Gets extremely loud. A lot of you are probably familiar with that. The thing is, they get extremely loud, but they don't really vibrate much. This thing at 100% vibrates quite badly. And I didn't even realize that. I just heard it making the noise. But then I went to feel the airflow behind it and touched the heatsink, and I felt it vibrating like crazy at a very high frequency because the fan was spinning. I'm assuming one of the blades is just slightly out of whack. Just ever so slightly, because at lower speeds it doesn't really vibrate noticeably. And it was making the whole motherboard vibrate. Like if I touched the DRAM, touched on the PCIe cards, I could feel them vibrating in tandem with it. Like it was basically shaking the entire motherboard. Not good for the board and the components on it, most probably. So I'm hoping this is just a faulty unit, because, as I said, there's not too many available in this low profile style with a built-in fan. So I may just try to get another one of these and hope this was just a specifically defective unit, or I may have to try to find a completely different model. Oh, and there's one more thing. Actually, let me just move this stuff around for a second. You might notice that the power LED is on, whereas I said before I connected the hard drive LED, but I did have a set with DuPont connectors and the crimp tool needed, so I crimped on a new end to this power LED cable, and now it sits in the appropriate place. And in addition to the power LED, we have the hard drive LED, we have S1 and S2, which is sensor 1 and sensor 2, I think. They're really meant to indicate the status of temperature monitoring, but you could use them for whatever. There's just two LEDs there. A fan monitoring LED, an alarm reset button. And with the exception of the power LED and the hard drive LED, the rest of these are wired up to this little connector, which I already started tracing out. And so I find the easiest and probably least LED destroying way to test these is just a coin cell battery, and I just have two wires that I'm just holding on either side of it. And if I have this right, this should light up the fan LED. And there we go. Fan LED. All I did was stick that in there. And then I believe this should be S2. Yep. And S1. And then the last two contacts there are the reset button. There's an alarm reset button there. So this computer is just about ready to go, but there is one more thing I want to test with it. Alright, so I've never done this before, but what I have here is a handheld smoke machine. I actually have a video coming out about this device. One of the reasons I bought it was for this kind of thing. Also for testing out LED lights and laser lights to show the beam dispersion better on camera. What I got here is a piece of acrylic on top of the server, and I think you can see where this is going. I'm kind of curious, you see there it is, to see what the airflow is like in this case. You can see I have the doors in the front open. That's because they have foam in them, and that foam is going to basically catch most of the vapor. So I'll do it with the doors open, plus it'll help to channel the air in here, so I could put the fog machine here-ish, and hopefully the fog collects there, then gets sucked into the case, and we can see where it goes. On top of that, I have this laser level. It's shining a horizontal beam of laser light across the case above the heatsink and the PCIe cards. So that might help to visualize it. I don't know. First time I've done any of this, but let's see what happens. Let me turn the lights down. Alright, so you can see we still got the acrylic on here. It's actually kind of hard to see now, which is the point. And what I'm going to do, I think, is just try to get a bunch of fog built up over here at this end, and then I'm going to turn the power on, and the fans will come on at full whack when I first turn power on, and should suck all this right through. I actually got to hit the power switch in here. Shit. Oh. Oh, yeah. And you can see it gets cleared out of there pretty quickly. Let me try it without the nozzle. I feel like the laser is not really doing much for us here. But what the laser is doing is interfering with the airflow technically, so I thought this would be more dramatic. You can see it's lasing, but it's not doing a heck of a lot. I mean, also I think the vapor is too thick, so the fan just spooled down from max. They were on max just now when the computer turned on. Now they're sort of closer to just a nice idle-ish. So let's see what we got here. Okay, you can see we basically have nothing on this side as far as inflow. But this fan at 2000 RPM is sucking it in pretty good. And it's blowing it all right out the back. So yeah, I mean, just since we have no intake fans on this side, you can see it accumulates there. It does get sucked in through this fan, but it kind of just sits there. And now, just for fun, I'm going to pull out this fan. That's going to cause the other fans to go up to 100%, I assume. Yep, the other fans are spooling up right now. Now let's see what this looks like. And it's kind of interesting because the CPU fan is moving more air than these two fans. So some of that air is getting ejected. Some of it is just hitting the back of the case, sort of going around. And then you get very turbulent air around the CPU. Wonder if I get a more oblique light on this, if that would be more visible.
Enhance 224 to 176. Enhance.
Move in. Pull out track right. Center and pull back. Track 45 right. Enhance 34 to 36.
Hand right.
And pull back.
Enhance 34 to 46. Pull back. Go right. Enhance 57 to 9. Track 45 left. Enhance 15 to 23. Hard copy right there.
So that method of testing by putting a fog machine in front of the server and having the air blow through it with plexiglass on top, or acrylic, whatever that was, worked great. It was very informative. I don't know that I'd recommend everyone do it for a variety of reasons, but what I did find out, and it wasn't a surprise, is that these two Noctua fans on the back, well, they're really good fans. I mean, I still stand by the purchase decision as far as the quality goes. They're just not high RPM, high airflow enough. Like, they just don't move enough cubic feet or cubic meters of air per minute or per whatever time segment you want to use to really evacuate air out of the case quickly. For example, if the CPU is running full throttle and other components in here are generating a decent amount of heat, these aren't really going to evacuate enough air, I don't think, out of these two small orifices in the back. Slower, quieter fans like these in a larger form factor would probably be fine. For example, if there were a couple of maybe 100mm fans on the back of this case, although then you'd have very little room for I/O. Or if we had a fan here instead of the power supply, that might be enough with 3 fans back here. And it did clear out the fog quickly enough. I think I'm just not confident in its ability to handle high heat and high load for a sustained period of time and actually evacuate enough of that heat to the outside of the case. But this fan I am going to keep, even though it's also relatively low airflow. Obviously, it's 2000 RPM max, just like these guys. But because it's a bigger form factor, it pushes more air. It's still not a ton. It doesn't blast a forceful amount of air, but it's enough to get airflow over here by the PCIe cards, which otherwise I think might be a bit starved. So that's staying. These 2 fans are getting replaced, as is this fan, because of the vibration. Otherwise, this package of heatsink and fan was fine, although I'd prefer something a little quieter at top RPM. This was quiet enough at sort of idle, which is what this server is mostly going to be at, that I was satisfied enough with it. It's the vibration that this was experiencing at high speed that scared me. I just don't like it. Even if it's not going to be running at high speed very much, if this server is mostly going to be at idle or not using much in the way of CPU resources, I still don't want to chance it throttling up and vibrating all to hell. And so to solve these problems, which I admittedly created myself, it's been about a week since I last shot any video with this server, and that's because I was waiting on this thing. This is a heatsink and fan designed for 3 RU systems. It should fit in this case nicely enough. It should just about come up to the top. If it doesn't fit, then we got problems, but I think it will. And it has a 80mm fan, compared to, I measured the other one that's in there right now is 55mm. So again, this one should be slower and therefore quieter for the same amount of airflow. And obviously the heatsink is also physically just larger. Also comes with thermal compound pre-applied, so I'm going to have to clean the old compound off the CPU, but it's going to be replaced with this. Now, I'm not sure about the Dynatron brand. I don't think I've ever used any fans from them before. The heatsink seems well enough made. This screws on as a separate assembly. I do like the fact that this is metal. Even though it doesn't really matter, it just seems like at least they're going for a little more quality than plastic. And this seems to be well made enough. I don't see any obvious problems with it. And I think this is rated for, I'll put it down below, I think it's rated for 300 watts max heat dissipation, but the CPU in this thing is only 125 watts TDP, so this should be more than enough for that CPU. In fact, this is technically overkill, which is obviously better than underkill when it comes to cooling. And before I decided to go the route of upgrading the CPU cooler, I wanted a couple of 60mm fans that were capable of higher airflow quick, and these were the only ones that Amazon or Newegg or anyone had in stock. 60mm computer case fans of this type are surprisingly hard to find, at least on the quick. I didn't really even care about the cheap. So these are from AVC. First thing I noticed was the pinout is wrong. Now that's not a big deal because, as you'll see, I can just put different connectors on these or reconfigure the pins on this connector. But that got me down a little bit of a rabbit hole where I just wanted to make sure that I connected the pins in the correct order, because you would assume red is V+, black is ground, and then one of these two is the TAC and one is the signal for the PWM. The rabbit hole part is that I wanted to look for a data sheet for these so I could verify what color wire corresponds to what signal, and I could not find any information about these fans from AVC or anyone else. I could not find the data sheet. I didn't look terribly hard, but I was just immediately disappointed and kind of concerned that their website did not have a data sheet for this, which makes me think they're not really selling this to professional end users or people who would want data sheets. The other thing that concerned me is the back of this looks a little grubby, and I don't know, the fan just feels cheap. So I was just not enamored. Even the leads just feel a little cheap and nasty and very stiff, and the insulation's a bit flimsy. I don't know. Just not quality fans, in my opinion. Didn't even test them, didn't even power them on. I just don't like them. I don't like the manufacturer either, just based on their website. So I went over to Mouser, where they have a wide selection of fans, a little bit more of a lead time, but since I decided I was going to wait for the CPU cooler, I figured might as well wait for these. I just put them back in the bags. Mouser shipped these rubber banded together, which was a little I felt, you know, weird, but hey, it's fine. And so as you can see, these are San-Ace 60s. I've used San-Ace fans before, made by Sanyo Denki? Shit, I don't know. In particular, I've used them in that chassis there, which came from eBay, and it came with, I don't remember what brand, maybe Delta fans that were quite loud, and the San-Ace fans were noted to be quieter, according to the data sheets, still moving the same amount of air, approximately. So I upgraded those. They were indeed a lot quieter, and they've been running in that chassis for 9 years now, and they haven't failed. So, good. So I was pretty chuffed with these. You can see they're not as thick as the AVC ones I got. Now, thickness doesn't necessarily mean anything, although some people, but generally that means it has longer blades, and therefore it moves more air, usually a higher torque fan. So it'll move more air for the equivalent RPM as like a thinner fan, generally speaking. Exceptions to every rule, depends on the blade design, etc. And I also got these Orion fans from the Deep South by the looks of it. No, actually, I really like the company name just because that makes me think of Knight Rider. Because Kit was made by Knight Industries, and that's who, not Michael J. Fox, David Hasselhoff worked for. Michael Knight. No, wait, his name was Michael Knight. So did he own Knight Industries? I haven't seen the show in friggin' years, so I don't remember. Got a little bit of glue there that just comes right off. Yeah, I wouldn't want to leave that next to a fan if that flakes off very easily. But anyway, these are relatively pricey fans. They seem good quality. I have no problem with them in particular. However, I did test them out side by side. These were not only loud, which you'd expect because they are, I think, double the CFM of the San-Ace ones that I got, and I think higher max RPM, and obviously much longer blades because this is much deeper. The problem wasn't just the noise. The problem was that it gave a horrendously loud whining noise. Like it was a high-pitched scream from these fans at max. And that wouldn't matter necessarily in a real data center where, well, I mean, if I was working there, it would matter. But it does matter in the basement where I don't want these screaming at me. And even at a relatively low RPM, after the BMC kicked in and it went down to sort of the idle speed, it still had a screamy quality to it. So I immediately decided not to use these. These still pulled plenty of air through them. I mean, these moved a crazy amount of air. They seem really good if that's what you need out of a 60mm fan and you don't care about the noise. Like, you could probably run a quad-rotor drone using 4 of these fans. I mean, it was like I could feel it pushing back against my hand. And the gyroscopic stabilization was quite astounding. Like, it really did not want to move off whatever axis I had it on. Then the San-Ace fans were not notably powerful, but they were moving, like I said, a lot of air. Definitely a hell of a lot more than the Noctuas I got. Again, nothing against the Noctuas. It's all down to the spec of the fan. I'm not saying don't buy the Noctuas. It depends on how much air you need to move, and I made the mistake of buying ones that were low CFM because I was so worried about noise to the point of my own detriment. And what you will notice is that both of these have connectors on them that are compatible with the motherboard, and the pinouts are correct, as does this fan. If you buy your fans from Mouser, unless they're specifically sold with connectors, which they're probably not, they won't have them. I only wired up one of the Knight Industries fans. Yeah, all these fans came with just tinned ends, and so I crimped on these connectors. I'm not going to return these. I have a thing where I like to keep shit like this as spare parts, even if it's dumb. Even if I'm never going to use them because they're too loud, but you never know. I might need to replace the fan in 2U server at a data center, and I might just pop these in. They're staying. So to summarize my findings, too shitty, too slow, too loud, just right. So let's swap them out. Now, belatedly, I'm realizing that since these didn't come with connectors, I could have spliced some more length onto these wires so I could route them neatly around and then plug them into the fan headers directly without using the extension cables that I use for the Noctuas. Now, this one does technically reach, but it would kind of just be hanging out in the air. I personally am not that bothered by that, but a lot of people will be. I don't think this one is going to reach. I mean, maybe if I rotated the fan so that it's closer. You know what, just for neatness sake, or at least quasi-neatness sake, I'm going to leave the extensions in there. Alright, now let's change out the heatsink. The interesting thing about this is that because this is, unlike, I mean, this fan, I guess, is removable, but you really have to disassemble this whole thing. And I'm not sure how easily that would come out. Obviously, this fan's really easy to replace. It just has 4 screws on this bracket. So, if this fan turns out not to be good, I know I can easily change it for another 80mm fan, no problem. And I could definitely do that without dismantling the heatsink, because this just screws on with 2 screws to the top of this. The airflow arrow shows airflow that way, so this fan would be behind the CPU and blowing air this way through the heatsink. So in theory, I could mount the fan this way, which would have the airflow going that way, but I could unmount the fan, turn the fan around, and then have the fan pulling air across the CPU. But then this fan would be really close to those two. And I'm worried about weird cavitations between them, or just, you know, the airflow getting really messed up in this area. Because generally, I think very turbulent airflow behind a fan, behind in the sense that the fan would be sucking that turbulent airflow into it, causes the fan to operate inefficiently. So I think we do indeed want it as spec'd here, with the fan on the back, blowing air across the heatsink. And this way we should get a nice, is it called a laminar airflow? Out of the back of this. Because any turbulence created by this fan should be smoothed out as it goes through these long ducts, basically. And so it should come out with a nice smooth airflow into these fans, which would then help discharge it without causing it to go all around here and cavitate and cause these fans to cavitate or whatever the hell. I'm kind of talking out of my ass. It's not my area of expertise, but it just seems to me that it's a bad idea to have one fan running at one speed, blowing air into the back of another fan running at a different speed. Especially their fans different sizes, they're going to have different airflow rates. Yeah, and there's 2 fans, not even just one. So I'm thinking I'll leave it with the fan here. This officially isn't my favorite CPU mounting technique. We have all the leading brands of anti-stink spray.
What funny names.
They should call it anti-static bags, not static bags. I guess they probably do call them anti-static bags in reality, but see, I mean, that was the factory applied heatsink compound. It seems like there's too much of it. Doesn't that seem like too much? I mean, probably not, because that's how it came from the manufacturer, but ugh. Alright. Hopefully it doesn't fall out. Good, it did not. And then before I actually tighten it down and mount it, I just want to make sure we have clearances for this. And I also want to check to make sure it's not going to be too high to close the case. It might be too high to close the case right now because it looks like it's about maybe 6 or 7 millimeters higher than its ultimate resting position. So let's just see what we're looking at here. Ooh, the case is touching it, but like barely. It's lifting it up by maybe a couple of millimeters on each side. So I think once this thing is tightened down, we'll be good. Take the fan off for now. The fan doesn't actually increase the clearance at the top of the heat pipes that we're touching as anal retentively as I possibly can, which is not very anal retentively because I'm very impatient, but I'm going to try to tighten these down as evenly as possible, even more so than last time. Okay, yeah, I think I screwed them down pretty evenly, so we should have pretty even heatsink compound application. Oh, and let me double check the case closingness. Oh yeah. I mean, it's like right at the top. It might even be just touching it, but like it can move, so it's not like pressing on it. But it is notable that with this heatsink in here in this exact case with this motherboard, I wouldn't want to like put anything heavy right there, because probably most of that weight would be borne by the motherboard. This is going to be in a rack. This isn't going to have anything pressing down on it. Oh, and as a side note to that, while I was thinking about the airflow and cooling of this case, I realized it had these holes in the top, which I hadn't remembered because I took this cover off pretty quickly and then never really played with it again or put it back on. It's also got holes on both sides like this. Now, I'm actually thinking that I might just put a smear of tape over all these vent holes here and the vent holes on the sides. The vent holes on the top probably not as important because I'll have a piece of rack mount equipment like very close to this, not resting on it, but you know, just right above it. So there won't be much airflow through here. But the side vents, there would be a lot of airflow through them, potentially, which is another good reason for the smoke test, because these are going to be the most powerful fans in the case. They're going to move the most air, right? So these are going to be sucking air out. Ideally, we want air coming from the front to the back, which is, for the most part, I think what will be happening. But the problem is, if these fans are really pulling in air hard, they're going to start pulling in air from the side vents as well, which will cause airflow to just go like that, not going over most of the motherboard components or the CPU. Now, the CPU will be blasting air into these fans, so that should get exhausted. So I'm not really too concerned. It shouldn't be too much of a problem. It's just I find these vent holes superfluous at best. I want front-to-back airflow. I don't really want random airflow from the sides. But that's just me. And you might think these vent holes might help with the PSU, but the PSU's fan is here on this side. Alright, and then I gotta reach in here for the power switch. And this will be at full fan RPM. Oh wow. Now that's moving it through quick, and it's not too loud. I mean, it's loud, but not crazy. Oh, wait, mistake. No one noticed that, right? That I forgot to actually plug in the CPU fan. Yeah, let's just all ignore that. Oh, I didn't screw on the CPU fan either, which shouldn't really matter, but it might be a little rattly. It's still vibrating quite badly. This fan sucks also. I mean, throttled down, it's fine. It's still a little vibratory. Yeah, I can still feel that it's out of balance. This CPU fan also sucks. Let me see if I can get it to vibrate on the ruler so that you guys can get an idea of the vibration, because you can't see it or hear it, really. I don't think that's really going to come through on the audio, but regardless, yeah, this is vibrating quite a lot. Not as bad as the other fan, because I think this is a slower RPM. Now I think I'm going to have to get a new 80mm fan. Like, cheap parts are just shit. I mean, and when I tested out the Orion and the Sanace fans, I just plugged them into the motherboard, one of each brand, held them each in my hands, and turned it on, throttled up to full speed before the BMC kicked in. No vibration at all. I mean, like, almost none. Like, I could not feel any vibration coming off the fans. Also, this fan, no vibration at all. But we power on because, I meant power on with the test, but we will also power on the system. We just get a bunch of fog just sort of sitting here. You can see there's not much air movement in front of the computer as is. I'm going to stick my hand in and turn it on. So you can see here the airflow is coming in this drive bay, mostly getting sucked right into the CPU fan and then blown out the back. It becomes hard to see back here, but that's essentially where the air is going. As I move it more towards the middle, you can see some of it starts getting sucked in by this fan and then blown. Mostly, I mean, the CPU fan is doing a lot of work right now, so most of that air is just getting sucked across the CPU, but you can see some of it is turbulently coming around the PCIe cards at least, which is good. Like, this is blowing some hard enough to get back to the PCIe cards without getting diverted directly into the CPU fan. And of course, this is at max fan speed, because right now the BMC hasn't kicked in, so it's in failsafe mode, where it's just using all its fans as hard as possible. Now it's throttled down to its sort of idle speed. Let's see what we got. And you can see much less, but you can see the air is really now getting caught by these two fans in the back. And you can really see it coming in and going out that way. And then if we come over here, we're getting a lot more airflow past the PCIe cards. Oh, you know what we should do? Where'd I put the VGA cable? Fuck. And hey, it looks like the computer did come up. At least I didn't kill the CPU when I was messing around with it. Alright, cool. So we know the CPU is working. The other thing I wanted to see is on the sides here where these vent holes are. I'm just using the computer case cover as a bit of a baffle here to keep the turbulent airflow from the rear of the case away from these vent holes. Yeah, so air is getting drawn in for the most part. But not a lot. Most of it's going right past those vent holes and sort of lingering over here. And what about on the other side? Oh, a lot more air is getting drawn into these. Yeah. And just by feel, these fans are pretty quiet. Like, I can hear them, but they're going to be barely audible when they're in the back of the rack. But they are moving a lot of air. Let me see if the smoke machine will adequately demonstrate that. Yeah, I mean, you could see how fast it's getting blown out of there, like as it comes across the surface. And how much is coming off the CPU? The CPU fan is going low and slow. The heatsink is warmer than I would expect for the CPU basically being at idle, and the fan is spinning very slowly. I mean, I could tweak that, and I can tweak that in the BMC settings, so it's not necessarily a problem. But again, I'm going to get rid of this fan anyway, because at higher RPMs it vibrates, so damned if you do, damned if you don't. And I don't know that I'll airflow test this again, so this might be the last one, because even when I replace this fan, I'm going to replace it with a similarly spec'd fan, probably something with a similar CFM at a similar RPM range. So and I just want to see if I can maybe make the smoke a little more visible. I tried sticking that laser level in there at first. You can see it's really smoky in here. And this time I remembered to disable the smoke detectors before doing this. So, yeah, fingers crossed that we don't have another problem tonight, like the other night. For more on that, not too much more on that, but see my video on the smoke machine itself. The video on this ends with an illustration of the catastrophe in dramatic form, unnecessarily so. So like I said, for the fog test, I didn't want to mount the tape drive, so we didn't get any fog in it, especially on the head, but now it's time to put it in the machine. Also just noticed, made in Japan, by the way. Hey, also made in Japan. Now, one unfortunate thing is this is kind of an old school case in that these drive bays are not toolless. So we actually have to remove this whole bracket, mount the drive to the bracket, and then mount the bracket back to the case. It's not the worst thing in the world, it's just, like I said, old-fashioned. And the filler blanks actually come out with that, which is kind of good. And they're metal, by the way, too. And like I said, I'm going to mount the tape drive in the sort of middle-ish one here, just so you get some airflow over it and airflow under it. Don't want to mount it upside down. And these are also good. I like the fact that these are pre-mounted so I can get it aligned and flush. And I know we're in a good spot. This is kind of fun though. I can't remember the last time I mounted a 5 1/4 inch device inside a computer. Actually, it was fairly recent in that it was a drive bay adapter to convert a 5 1/4 bay into multiple 2.5 inch drive bays, but I'm not really counting that because that's, like I said, more of an adapter. It was a glorified bracket. This is actually a 5 1/4 inch device going into a 5 1/4 inch bay. Not something I've done recently. I mean, back in the day, I've been fiddling around with computers since the days of like 5 1/4 inch full height MFM drives. I mean, those were a little before my time, but I've always worked with slightly outdated stuff because it's cheaper. So, yeah. Ooh, I may have to mount it in the top drive bay, actually, just because of clearance issues. Yep. Okay. Well, unfortunate, but not a deal breaker. The drive actually does crush down this cable. It will fit, but this cable would be horribly pushed down. That's the ATX power connector adapter. Otherwise, it would fit fine. In the top drive bay, it'll definitely fit, no problem. So, yeah, okay. It is right side up, by the way. And then this should go in here without issue. Yeah, it's not impinging upon anything. All right, let's see where we are with style points. Well, it's there. And obviously it's perfectly accessible. We can get tapes in and out, no problem. It's just, you know, I think it would have been visually better also to have it right in the middle, but hey, best laid plans, best laid plans. Now, as for cabling, I got a couple of different options just because I am kind of a nut like that. This one is a mini SAS connector to this kind of SAS connector. And this has Molex plugs on it. I'm not going to use this one, I don't think. This one's probably a little more suitable. As you can see, it's for 4 drives. I'm not going to use 4 drives, so we'll just have to tuck the other 3 out of the way. So as you can see, mini SAS connector on this end, and then I forgot the name of this connector. I always forget the name of the connectors, but it's this style that attaches to the drive. It's got the 2 data cables coming out the back, and then a standard SATA style power connector. And we could connect this to the PSU, therefore sending power to the drive that way, and getting data communication to and from the drive that way. So it's nothing complicated. The only complicated thing is going to be routing all these cables neatly. I wish the PSU came with one of these that was just a single SATA connector if you just had one device. You don't have all this extra crap in there, but it did not. I mean, technically I can make up such a cable, but it's not that important. That's connected for SATA, and then connected to the drive. Now, in theory, we should have a working tape drive. So, cool. And none of these cables are under a lot of stress or tension. Everything's nice and loose and easy going back there. So yeah. Oh, one other thing. I also took the SFP out of the network card for the fog test and just covered it with a piece of tape. Like a USB port. I always put them in the wrong way first. There is one other card I kind of want to put in this machine, more or less for fun. Well, not really for fun. One second. I'm not even sure I want to put this in here. It's not what you'd call server grade, but this is a USB card. Obviously, it's got 2 Type C's and 2 Type A's, and they're powered because of the SATA power input. I'm kind of thinking I might pop this in here. The reason being, for USB-C high-speed ports with power, this way I can run external SSDs on this without a problem and get good throughput, because I may want to use this machine as a backup machine, also to back stuff up to an SSD, or just to copy video files to an SSD before I go on a trip or something. Kind of stupid because I could do that for my desktop computer, but kind of wanted the option. Also, in case I wanted to sneakernet files from, let's say, the data center for work or the office back home to back those files up to a tape for long-term archival storage, better than transferring it over the VPN, which is what I do now. I can plug that in there, no problem, but then what am I going to do? Have that sitting right in front of the CPU fan? Or all this crap right behind the heatsink? I don't like that. You know what? I think the USB card will still work without the power. The power is just for powering devices. I'm guessing that I'll still be able to supply enough power off the motherboard PCIe slot to run an SSD or a USB thumb drive or something like that. Alright, well, that's pretty much it. Only thing I'm going to do is replace that 80mm fan on the CPU heatsink. But while I'm waiting for that to arrive, I'm going to install an OS. I'm going to play around with Bacula, at least at first. And of course, I'll mount this in the rack behind me once I get the fan finalized. That's my plan. Not going to include the fan replacement in this video. I mean, it was pretty simple. That bracket comes off, 4 screws, new fan, blah, blah, blah. I'll probably order that fan off Mouser as well, unless I see a good fan somewhere else. And I'll go with SanAce again. Otherwise, this thing is ready to go. I will be back in the future, possibly the distant future, with a video talking about my experiences with the backups, what backup software I ended up using, some basics around it. I'm not going to necessarily go into a full tutorial about Bacula or whatever it is I end up using, but I will show what I've done. But this video is more than long enough as it is, because there were a lot of stops and starts and pitfalls. But overall, I'm pretty happy with how it turned out. It's not like the sexiest machine alive, but it will work for my purposes, and ultimately I'm glad I went with rack mount. I'm glad I went with something that has foam filters in the front, so I can keep the dust down, keep the dust away from the tape drive most importantly. And, you know, this would also be a good solution if you had this in some area where people were maybe coming through, because you can physically secure the front of it with a key. So if you had a tape backup going, that gives you a little bit of a physical layer of security from someone popping out the tape and running away with it. That being said, the case is a little cheap in parts. The bracketry that holds the 5 1/4 inch drive bays and some of the other stuff in there, it's kind of questionable. They'd like use standoffs and it seemed very kludgy. And the power supply in the front, you know, it's fine. Like I could see there might be reasons for that. They do sell a version without the power supply in the front. They do sell a version of this case with power supplies pre-installed. I would say I made a mistake by going with this version because I didn't end up using the power supply in the front, but based on the quality of the case, I kind of question the quality of the included power supplies. Can't really talk dirty about them because I haven't personally tried them. I'm just not confident in their quality, and they're probably noisy. They probably have loud fans in them. This PSU, very quiet. The fan didn't even turn on yet. Overall, I mean, I'm pretty happy with the way this thing came out. Time will tell, of course. And thank you for watching all this nonsense. Anyone with angry comments, please leave them below. Sure I did plenty of things wrong. But hey, this is actually the first rack mount server that I've built from scratch. And I put from scratch in quotes because it's not like I made the case, you know, and like fabricated the motherboard myself. But you know what I mean. This is the first rack mount computer I've ever made from scratch, more or less. Although I did heavily mess around with that super micro case behind me. But yeah, this was the first one of its kind for me. So that's kind of interesting. Anyway, I'm rambling. Bye.